Chapter 5, Section 8 is on graphing systems of inequalities. So it's taking what we did yesterday and then adding a level of difficulty by graphing a line, more than one line at a time. So some of our terminology is going to be that the solutions of the system of linear inequalities is where they overlap. The boundaries are always part of the solution, and the intersections are called the vertices. So those are kind of some of your terminology when we are looking at systems of inequalities. So if we take a look at example A, the first thing I'm going to do is kind of graph the first line just like I would yesterday. So that is already in slope-intercept form. So I'm going to start up at 5, put my ordered pair. It has a slope of -2, so I'm going to go down 2 and over 1. It is a greater than sign, so that is going to leave me with a dashed line. And then just like yesterday, I'm going to test 0, 0 here. So 0 greater than 0 plus 5. 0 is not bigger than 5, so that is false, meaning that I'm going to shade away from that, the true side. And instead of shading, I'm just going to draw myself some arrows, meaning I'm going to shade on the right side of that blue line. Now when I go to graph my second line, I'm going to start with my y-intercept again, which is -3. I'm going to graph my slope of 1/4, which is up 1 over 4. That is a less than or equal to sign, so that is a solid line. Okay. Again, I'm going to test 0, 0. So I've got 0 less than or equal to 0 minus 3. 0 is not less than -3, so that is false, meaning I'm going to shade away from 0, 0. So again, I'm going to just kind of draw myself some arrows. And like we said, our solution area is the overlap of those two. So our shaded region is over here. In order for that to work really well, you're going to want to make sure that your lines are drawn all the way through the graph so that you can clearly see where they intersect, leaving you with kind of 4 different options, and then just shading darker if you're shading your final solution. Okay, so example A. Let's try example B. So the first line in example B is written in standard form. So I graph these by using the XY chart. So if X is 0, then Y would be 6. If Y was 0, then X would be 2. So I'm going to graph my 2 order pair 0, 6 and 2, 0. Okay, if you don't like using the XY chart, then you would just rewrite that for Y equals MX plus B and then graph it as usual. But either way, it's a less than or equal to sign, so that is a solid line. I'm going to test 0, 0. So I've got 0 plus 0 less than or equal to 6. That is true. So I'm going to shade towards 0, 0. So I'm just going to draw myself some arrows so I can see what my other graph looks like. My second line has a y-intercept of 2 and a slope of 2/3. So I'm going up 2 and over 3. And it is also a less than or equal to sign. So that, oops, that should go through those points. That should be a solid line. Again, I'll test 0, 0. So I've got 0 less than or equal to 0 plus 2. That is true. So I'm going to shade with 0, 0. And then where those 2 lines overlap is going to be my answer region. So this big shaded region down here. Okay, so just like you did yesterday, only 2 or more lines at one time. So example C's got 3 lines. Okay, so I'll graph that first one. So it's got a y-intercept of 3 and a slope of -1/4. So I'm going to go down 1 and over 4. It is a less than or equal to, so that's a solid line. Again, I'll test 0, 0. So I've got 0, oopsies, 0 less than or equal to 0 plus 3, and that is true. So I'm going to shade with 0, 0. My second line is a y equals, and y equals is a horizontal line. Okay, and 0 happens to be right here. And then shaded above because that's greater than or equal to. X is my vertical line. Okay, maybe you just want to make yourself note that you can tell the difference. Greater than or equal to 0 is actually the y-axis right here. And then shaded to the right of that. So now what you're looking for is an area where all 3 lines overlap. So I need to be the right of the red, above the green, and below the blue will be this triangle in there. Okay, it's kind of pretty, at least in my mind. All right, we'll try one more. We've got example D. So line number 1 again is in standard form. So I'm going to make an XY chart again. So if X is 0, Y would be 2. If Y is 0, then X would be 4. So I've got 0, 2, and 4, 0. That's a less than or equal to, so that's a solid line. I'll test 0, 0. So I've got 0 plus 0 less than or equal to 4. That is true. So I'm going to shade towards 0, 0. My second line is also in standard form, so I'll make another XY chart. So if X is 0, this time Y is 4. If Y is 0, X is 2. So this time I've got 0, 4 and 2, 0. And that is also a solid line. Okay, I'll test 0, 0. So I've got 0 plus 0 less than or equal to 4. That's also true. So I'm also to the left of the green line. Y is greater than or equal to 0 is horizontal, and X is vertical. So I've got my X-axis and my Y-axis. And I need to be above and to the right of those. So this time I'm looking for the intersection of all 4. So to the right and above both reds, below the blue and below the green is this little square quadrilateral down there. Okay, so graphing 4 systems, 4 lines or 5 lines or 3 lines or 2, always looking for the overlap of all of them. Okay, so that's all I have. Maybe kind of confusing, so write down some questions and bring them to class tomorrow.